In this episode, we move into a part of security management that can feel uncertain at first because emerging risks rarely arrive with a clean label and a simple answer. Artificial intelligence, AI, quantum computing, and the Internet of Things, IoT, are often discussed as if they belong only to engineers or futurists, but they are management issues just as much as they are technical ones. A security leader does not have to predict the future perfectly to handle these topics well, but that leader does need to notice change early, understand what could matter to the business, and make reasonable decisions before small uncertainties become large problems. That is what makes emerging risk management so important for new learners. It is the discipline of paying attention to what is changing, separating hype from real exposure, and deciding how much action is needed now versus later. When you understand that mindset, these technologies become much easier to think about because the job is not to panic, and it is not to ignore them, but to manage them with structure and judgment. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. An emerging risk is not simply a new technology or a new headline. It is a risk area where change is happening faster than normal controls, ownership, and understanding can keep up. Known risks usually come with history, patterns, established guidance, and mature ways to respond, while emerging risks often come with incomplete information, unclear accountability, and a wide range of possible outcomes. That uncertainty is what makes them hard for organizations to handle. People may overreact because the topic feels new and dramatic, or they may underreact because the danger is not yet visible in a painful way. Good security management lives between those two mistakes. It treats emerging risk as something to observe, interpret, and govern over time. The goal is not to claim certainty where none exists, but to create enough visibility and discipline that the organization can move early when needed and avoid being surprised by a threat that was visible in pieces long before it became obvious to everyone. Identifying emerging risks starts with paying attention to change in the business environment, not just the threat environment. If a company adopts new tools, expands into connected operations, depends more heavily on vendors, stores more valuable data, or automates more decisions, the risk picture changes whether anyone says so out loud or not. Security managers therefore need to watch business plans, technology roadmaps, procurement decisions, regulatory pressure, and operational trends all at once. A new marketing platform using AI may create data exposure concerns. A new smart building rollout may quietly add hundreds of connected devices. A vendor pushing new cryptographic roadmaps may signal that quantum-related planning is becoming more relevant than it was a year earlier. Emerging risk identification is really an exercise in pattern recognition. You look for areas where technology, business dependency, attacker interest, and weak governance are starting to meet in the same place, because that is often where tomorrow's major risk begins as today's small but noticeable signal. AI is a useful place to begin because it is already affecting daily work in many organizations, often faster than security policies are adapting. At a high level, AI refers to systems that perform tasks associated with human judgment or pattern recognition, such as generating language, classifying information, spotting anomalies, recommending actions, or summarizing large volumes of content. The business appeal is easy to understand. Leaders see opportunities to move faster, reduce manual effort, improve customer interactions, and gain insights from data that would otherwise be hard to process. The risk appears because speed of adoption often outruns clarity of control. Employees may start using external tools before approval exists. Sensitive information may be pasted into systems with unclear data handling rules, and managers may begin trusting machine-generated output without fully understanding its limits. That combination of usefulness and uncertainty makes AI an emerging risk area even when no one is acting recklessly, because the technology can spread across ordinary work faster than governance can catch up. The risks around AI come from more than one direction, and that is part of why the topic needs careful management. Attackers can use AI to scale social engineering, write more convincing messages, improve impersonation attempts, or process stolen information more efficiently. At the same time, organizations can create their own problems by relying too heavily on AI output that sounds polished but is incomplete, biased, misleading, or simply wrong. A large language model, LLM, for example, can produce an answer that feels confident enough to influence a decision even when the reasoning underneath it is weak. There is also the issue of data leakage, because an employee may reveal sensitive material to an external service without realizing how much context has just been exposed. On top of that, if AI systems are tied into workflows that affect customers, hiring, fraud review, operations, or security analysis, mistakes in those systems can create legal, ethical, and business consequences that go far beyond a bad technical result. Managing AI risk begins with treating it as both a technology issue and a governance issue. An organization needs to decide where AI use is allowed, what kinds of data can be used with it, who approves new use cases, and what level of human review is required before generated output influences an important action. This does not mean banning everything new until the excitement fades. In many cases, a better approach is controlled adoption with clear boundaries, because useful innovation will happen anyway, and unmanaged experimentation is usually riskier than guided experimentation. Security leaders should work with legal, privacy, operations, and business teams so the rules reflect real work instead of wishful thinking. Vendor questions matter as well, because a company should understand how a provider stores data, how models are updated, how customer content is separated, and what contractual responsibilities apply if something goes wrong. The healthiest AI programs treat machine output as assistance, not authority, and they make sure accountability still belongs to human decision makers. Quantum computing creates a very different kind of emerging risk, because its biggest security impact is less about what most attackers can do today and more about what may become possible over time. The main concern is that sufficiently advanced quantum capability could weaken some of the cryptographic methods that protect data, identity, and trust across modern digital systems. Cryptography, in simple terms, is what helps organizations keep information confidential, verify that a message or system is authentic, and protect the integrity of sensitive exchanges. Much of modern business relies on those protections even when users never see them directly. That is why quantum risk matters to management even if the danger does not yet feel immediate in a day-to-day operational sense. The real challenge is timing. If an organization waits until change is urgent, it may discover that important systems, suppliers, applications, and contracts are deeply dependent on methods that are difficult to replace quickly. Emerging risk management exists precisely for situations like this, where the transition may take years even if the threat becomes serious only later. One of the most important ideas in quantum risk is that data value and data lifespan are not the same thing. Some information matters only briefly, while other information needs to remain protected for many years because it concerns intellectual property, government obligations, health records, legal matters, or strategic plans. That long time horizon changes how security leaders think about quantum exposure. Even if a certain form of decryption is not practical today, organizations still have to ask whether an attacker could capture protected data now and hold it for future analysis if cryptographic capabilities improve later. This is sometimes described as a harvest now, decrypt later concern, and it matters because the damage would be delayed rather than immediate. A company that handles long-lived sensitive information cannot dismiss quantum risk just because no current incident is happening. It needs to understand which systems rely on vulnerable cryptographic assumptions, which business processes depend on them, and which classes of data would create the most serious impact if their protections became weaker over time. Managing quantum risk does not require panic, and it does not require a beginner to become a mathematician. What it does require is preparation in areas that are very familiar to good security management. Organizations should understand where cryptography is used, which systems are most dependent on it, which vendors are planning transitions, and where long-lived sensitive data deserves the most attention first. This is often described as building cryptographic agility, meaning the organization becomes better able to change its protective methods without rebuilding everything from scratch each time standards evolve. That is a management advantage, not just a technical one, because it reduces future disruption and allows change to happen in phases instead of under crisis conditions. Leaders should treat quantum planning as a roadmap issue connected to architecture, procurement, vendor oversight, and lifecycle management. The best posture is neither denial nor drama. It is a steady program of awareness, inventory, dependency mapping, and time transition planning tied to business value rather than to sensational predictions. IoT introduces another kind of emerging risk because it spreads computing into physical spaces and ordinary business operations in ways people may barely notice at first. Many connected devices do not look like traditional computers, but they still process information, communicate across networks, and depend on software, configuration, and access control. Cameras, badge systems, sensors, smart lighting, industrial monitors, building controls, medical devices, and logistics trackers can all become part of the security picture once they are networked and relied upon. The risk grows because these devices are often purchased for convenience, efficiency, safety, or analytics rather than through a mature security review process. They may be owned by facilities, operations, healthcare teams, manufacturing teams, or outside vendors instead of by the central technology group. That means the organization can become more connected long before it becomes more governed. IoT risk is not just about the device itself. It is about the sudden growth of hidden dependencies in environments where security ownership may be weak, fragmented, or assumed rather than clearly assigned. The danger with IoT is that weaknesses can multiply quietly across large numbers of devices while remaining hard to see. A single poorly managed sensor may seem unimportant, but hundreds of them spread across offices, stores, clinics, or plants create a very different situation. Some devices are difficult to patch, some are supported for only a short time, and some arrive with limited logging, limited authentication choices, or poor integration with normal monitoring tools. Others sit close to important business processes, which means a security issue can become a safety issue, an operational issue, or a continuity issue rather than just a data problem. If attackers gain access through a neglected connected device, they may use it as a foothold for broader movement or as a point of disruption in a system that was never designed for constant hostile pressure. The risk becomes even more serious when IoT intersects with operational technology, OT, because connected digital weaknesses can then affect real-world processes such as manufacturing, environmental control, physical access, or critical service delivery. Managing IoT risk begins with knowing what exists, who owns it, and why it is connected in the first place. That may sound basic, but asset visibility is often one of the weakest areas in connected device environments because devices are bought by many departments and introduced through many different channels. Good management also means deciding what security expectations must be met before a device is purchased, how it will be supported, how updates will be handled, what network access it truly needs, and when it will be retired. Segmentation matters because not every connected device should be able to interact freely with every other business system. Lifecycle thinking matters too, because a device that cannot be supported or monitored safely may become a long-term weakness even if it was convenient at deployment. Strong IoT management is therefore less about chasing each gadget individually and more about building a repeatable governance model that covers procurement, ownership, configuration standards, vendor accountability, change management, and end-of-life decisions before the environment becomes too large to understand. When you step back, AI, quantum, and IoT look very different technically, but from a management perspective they share a surprising amount in common. Each one creates uncertainty because business value appears quickly while full control maturity arrives slowly. Each one can spread across the organization through ordinary decisions made by teams that are not trying to create risk at all. Each one also challenges traditional security assumptions. AI changes how decisions and content are produced, quantum challenges long-term trust in current protections, and IoT expands the number of connected assets far beyond the laptop and server model many people still picture when they think about cybersecurity. That is why good emerging risk programs rely on repeatable practices instead of one-time reactions. They scan for change, assign ownership, document dependencies, evaluate business impact, and review whether current controls are still matched to the environment that actually exists rather than the one people assume exists. A mature response also depends on communication, because emerging risks are often misunderstood at both ends of the spectrum. Some leaders hear a new term and immediately imagine an urgent crisis, while others assume the topic is distant, academic, or mostly marketing language. Security managers have to translate the issue into plain business terms without overstating or minimizing it. That means explaining what the technology is changing, where the organization is exposed, what the likely business effect would be, and what sensible action looks like now. In some cases, that action may be immediate control work. In other cases, it may be monitoring, policy updates, contract language, architecture planning, or a limited pilot with guardrails. The point is not to pretend every emerging risk demands the same kind of response. It is to make sure the response is deliberate, proportional, and connected to the organization's real dependence on the technology. When leaders understand that, they are more likely to fund preparation early instead of waiting until the issue appears in headlines attached to someone else's failure. By the end of this discussion, the core lesson should be clear. Identifying and managing emerging risks is less about predicting every technical detail and more about building a disciplined way to notice change, evaluate impact, and act before uncertainty becomes damage. AI matters because it can spread quickly into daily work and affect decisions, data handling, and attacker behavior. Quantum matters because long-term cryptographic dependence creates planning needs well before disruption is obvious. IoT matters because connected devices extend digital risk into physical operations, often with weak visibility and fragmented ownership. For a new learner, the most important habit is to think like a manager of change rather than a collector of scary headlines. Watch where the business is going. Ask what is becoming more connected or more trusted, and then make sure ownership, governance, and control maturity keep pace. That is how emerging risk becomes manageable, even when the technology itself is still evolving.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.